Welcome to a session on solar cell. A solar cell is a PN junction that can generate electrical power when illuminated with sunlight. Simply, it will convert solar energy into electrical energy. The, they operate under photovoltaic mode, which means that if the diode is left on open circuit, an externally measurable voltage appears between P region and N region. So, this is the symbolic representation of a solar cell. This is the construction of the solar cell. Here you can observe this is the P region and this is the N region, and this is the top electrical contact and this is the bottom electrical contact, and this is the external circuit. This is the single solar cell and this is the series of solar cells. And this solar cell is also called as a photovoltaic cell, PV cell. Let us see the construction. It consists of a P-type chip on which a thin layer of N-type material is grown. So as I told you, this large region is called as a P region, and this is P region is very thick, and on this P layer a thin N layer is grown, and this N layer is very highly doped. The N region is heavily doped, it is also thin, so that the light can penetrate through it very easily. So light has fall to into the PN junction through the N region. That's why N region should be very narrow. The P region is lightly doped, so that most of the depletion region lies in the P side. Here, P region is very lightly doped. Due to that, this PN junction mostly deeply extend into the P region. It also consists of a glass cover and anti-reflection coating. So on the surface, it consists of a glass and anti-reflection coating. The front and back contacts are metallic contacts for the flow of electrons. So here these are the front electrical contacts and this is the back electrical contact. When external circuit is connected to these front and back electrical contacts, a current will flow. Electron hole pairs are mainly created in the depletion region, and due to the built-in potential and electric field, electrons move to the N region and the holes to the P region. So the same internal photoelectric effect is the principle behind the working of solar cell also. Whenever a photon is falling on the junction part, PN junction, it will separate electron and hole, or it will create a electron hole pairs. The built-in potential will separate electrons and holes. So the built-in potential pushes the electrons into N region, pushes the holes into P region. So N region is having excess electrons, P region is having excess holes. When we connect these two regions with the help of a voltmeter, it will give a potential difference or a voltage. So this is the working of a solar cell. Let us discuss some of the VI characteristics of the solar cell. The IV characteristics depends upon the intensity of the incident radiation and also the operating point of the cell. If the external circuit is short circuit, then the only current is due to the generated electron hole pair by the incident radiation. This is called as a photocurrent, denoted by IPH. IPH means photocurrent. I for current, PH for photo. Another name for this is the short circuit current. So in short, it is also called as ISC, a short circuit current. The photocurrent is related to the intensity of the radiation, IOP, by IPH. Photocurrent equal to K times incident radiation intensity, where K is the equivalent to an efficiency metric that measures the conversion of light into electron hole pairs. When external load R is connected, it develops a voltage. This voltage opposes the built-in potential and reduces the barrier for carrier injection across the junction. This is similar to the PN junction in forward bias only. This forward bias current opposes the photocurrent generated within the device due to the solar radiation. This is because I photocurrent or photocurrent is generated due to electrons going to the N side and holes to the P side due to the electric field within the device. This is also called as a drift current. The forward bias current is due to the diffusion current, that is electrons going to the P side and holes going to the N side. The net current can be written as I equal to minus IPH plus IDE. So this is the symbolic representation of the IV characteristics. And we can calculate maximum power by multiplying Vm with Im. And ideal power can be calculated by VOC into ISC. Let us see some more characteristics. Efficiency we can calculate as useful power Pmax divided by input optical power. This also can be written as useful power Pmax divided by light intensity into area of solar cell into 100. So a single solar cell can generate a voltage of 0.5 to 0.6. To enhance the voltage, so we can connect a number of PV cells in, so that we can generate large amount of voltage. Thanks for watching.